Welcome to 3D visualization of brainstem pathways and cranial nerve nuclei with an introduction to infarcts. All 3D models in this video have been sourced from imaging scans of real patients. We will first begin with brainstem gross anatomy. The brainstem is made of three major parts, the midbrain, pons, and medulla, with the pons being connected to the cerebellum by the middle, inferior, and superior cerebellar peduncles. The human brain has 12 pairs of cranial nerves. Nerves 3 through 12 emerge from within the brainstem itself. Cranial nerve 3, the oculomotor nerve, 4, the trochlear nerve, and 6, the abducens nerve, function to control the muscles of eye movement. Cranial nerve 8, the vestibulocochlear nerve, relays information from the organs of hearing and balance. Cranial nerve 5, the trigeminal nerve, provides sensation to the face and motor innervation to the muscles of mastication. Cranial nerve 7, the facial nerve, provides motor innervation to the face and taste sensation to the anterior tongue. Cranial nerve 10, the vagus nerve, is a multimodal nerve with many functions throughout the body. Cranial nerve 11, the spinal accessory nerve, provides motor innervation to muscles in the neck. Cranial nerve 12, the hypoglossal nerve, provides motor innervation to muscles of the tongue. Many of the cranial nerves connect to and have multiple nuclei, including nerves 3, 7, 9, and 10. These nuclei allow nerves to work together to perform tasks in the body. Now for an introduction to brainstem pathways. First, we'll start with ascending tracts. The dorsal column medial lemniscus is a sensory pathway that enters the spinal cord through the dorsal root ganglion. It ascends to the medullary pyramids where it decussates, or crosses over midline, and finally terminates in the ventral posterolateral nucleus of the thalamus. It senses fine touch, two-point discrimination, vibration, and proprioception. The anterolateral system, or spinal thalamic tract, is another sensory pathway that originates in the skin and enters the spinal cord, where it decussates within 1 to 2 levels. It also terminates in the ventral posterolateral nucleus of the thalamus and senses pain and temperature. Now for descending tracts. The cerebrospinal tract is a descending motor pathway that originates within the red nucleus of the midbrain and descends ipsilaterally to act in flexion of the upper extremities. The corticospinal tract is a primary motor pathway that originates in the cerebral cortex and descends to decussate at the medullary pyramids, which innervates contralateral body movement. Finally, the brainstem includes a few other important structures, including the red nuclei, periaqueductal gray, substantia nigra, medial longitudinal fasciculus, and inferior olivary nuclear complex. Now that we've learned many of the key players in brainstem function, we can begin to look at brainstem infarcts. One classic brainstem syndrome is lateromedullary or Wallenberg syndrome. This occurs due to an issue in vascular supply of the posterior inferior cerebellar artery. The disruption in blood flow causes ischemia to the posterolateral section of the brainstem and causes a multitude of problems. Here we have a brainstem fading out to transparent and highlighting the slice we'll be looking at to describe lateral medullary syndrome. Symptoms include ipsilateral sensory facial loss of pain and temperature, as well as ipsilateral facial pain due to damage of the trigeminal nucleus, ipsilateral ataxia of the arm and leg, as well as gait ataxia due to damage of the rustiform body of the cerebellum, ipsilateral nystagmus and vertigo due to damage of the vestibular nucleus, ipsilateral hoarseness and dysphagia due to damage to the nucleus ambiguus, ipsilateral Horner syndrome due to damage to the descending sympathetics, contralateral hemisensory loss of pain and temperature due to damage of the spinal thalamic tract, and hiccups. Thank you for watching this video. Please be sure to check out some of the other videos from MUCOM's 3D Visualization Laboratory.